Hi guys, today we are going to be dividing polynomials. First we will divide by using long division, and if possible we will then divide by using synthetic division. But let's go ahead and talk about long division. So we're going to do stuff like this. Okay, so before we begin to divide, we need to make sure we have a few things in order. One, go ahead and look at your divisor. That's code for whatever you're dividing by. Look at your divisor and make sure it's in descending order. If it's not, fix it. So let's go ahead and fix it. So in this case the degree is 2, so it would be nice if we had an x to the second, x to the first constant. We don't have an x to the first, but it's okay, just put it in descending order and you're good. So x squared is positive and 3 is negative. Cool. Okay, so again, when you are using long division to divide polynomials, look at your divisor. That is code for whatever you're dividing by, and make sure it's in descending order. If it is, cool, and if it isn't, fix it. What else do we have to make sure is good to go? We also have to look at the dividend. Okay, that is code for what are you dividing into. The dividend, not only does it have to be in descending order, we need to make sure we have a term for each power going down, including the constant term. So this is how it's going to go down. So the degree is 5, so it would be nice if we had an x to the 5th, 4, 3, 2, 1, blah stuff, or degree 0. But as you can see, we don't have some of those, so we're going to have to use some 0 placeholders. The reason why we call them 0 placeholders is because we will be using the number 0 to reserve the place of the missing power of the variable. So the degree is 5, so we have an x to the 5th. We do not have an x to the 4th, so we want to put a reservation. We're going to put a 0 placeholder, so we're going to use the number 0, okay, to reserve the place of the missing power of the variable term. But the thing is, we're going to write 0 in a very special way. We're going to write 0 as 0 times x to the 4th. Do you really have to do that? No. Do you even need a 0 placeholder? No. But I recommend you do so things line up. The reason why we write 0 as 0 times x to the 4th is to highlight that this is where the degree 4 term should be. So let's do this. We have an x to the 5th, 0 placeholder for x to the 4th. Do we have an x to the 3rd? Yeah, we do. So let's go ahead and write it. So we have minus 3x cubed. So we have 5, 4, 3, 2. Do we have a degree 2 term? No. So another 0 placeholder. So plus 0, and we will write 0 times x squared. Okay, so we have 5, 4, 3, 2, 1. We have a degree 1 term, so let's go ahead and put it down. And it kind of looks like we have everything, but it's a lie because we have 5, 4, 3, 2, 1, and I need a blast off. Okay, so we need a degree 0 term, and the degree 0 term is your constant. Okay, cool, yeah. And then once we have this set up, so once we have made sure we're good to go, meaning making sure that our divisor is in descending order, making sure that our dividend is in descending order, and there's a term for each power going down, including the constant term, we are ready to good to go. We are good to go. Sorry about that. The question is, how do we divide? We're going to divide using the same process as we divide whole numbers. You know, you divide, multiply, subtract, and all that good stuff. Let me go ahead make up a bonus problem. So let's pretend that on a paper you were asked this question. 12 goes into, how many times does 12 go into 329? Okay, so the question is, oh well, how would I do that? You're like, it's easy, we got this. So first things first, we need to divide. So 12 does not go into 3, but 12 will go into 32 at most 2 times. What do we do thereafter? Multiply. What do we do thereafter? Subtract. You got this. Okay, if you can do this, I kid you not, you can do this problem. It's just gonna be a little bit spicier. Okay, so we divide, multiply, subtract, and I believe that gives me I don't even know what that gives me. 8. I'm trying to show off in front of you. Sorry. Alright, cool. So we're going to divide, multiply, subtract. If there's another digit, we bring it down. And anytime we bring something down, we got to repeat the division cycle. Divide, multiply, subtract. Okay? So 12 goes into 89 at most. Who knows their times tables? Okay. 12 goes into 89 at most 7 times. And then we multiply. And then we subtract again. Now, we are way too cool to write like a decimal, okay? So we just want old school answers. 12 remainder 5, like when you were in preschool. Cool. But later on, someone said, write the remainder as a fraction. Okay, so someone said, let's take the quotient and then add to it the remainder in fraction form. So we have said quotient plus remainder over divisor. So the quotient is 27. And then we're going to add to it the remainder in fraction form. The remainder is 5. We divide it by 12. So I guess we can write this as 27 plus 5 twelfths. But we can write this as a mixed number. Yeah, so that will be 27 and 5 twelfths. We wouldn't be able to do that with polynomials, but for this problem we can. So the reason why I put this problem is not because it's gonna be on the test. It's not. You're too advanced for that. Okay. I wanted to point out that if you can do this problem, you can do the problem that we're gonna attack. It's just you just have to take your time. The steps that you're gonna do are the same steps that you did to knock out this problem. So let's do this. Okay. So we are asked to divide. And we really don't have to be told to write our answer in the form quotient plus remainder over divisor. It's just the instructor was nice enough to put that. You know, we want you to get all your credit. Okay, so let's go ahead and divide. The question is, do I really have to use long division? To answer that question, ask yourself, are you dividing by more than one term? If the answer is yes, then yeah, you have to use long division. So are we dividing by more than one term? Yeah, cool. All right, so let's go ahead and do long division. But let's prep it up. Let's go ahead and look at the divisor and then make sure it's in descending order. 0 placeholders are not required for the divisor, but if that's what you need to make you happy, then go for it. So we have x squared. I believe 3 is positive. And I want to know how many times does it go into the dividend. So the dividend, there's two things that need to have been met. One, is it in descending order? And two, is there a term for each power going down? Okay, so in this case, the biggest exponent on any of the variable terms is 5. So when we put it in descending order, we should have an x to the 5th, 4, 3, 2, 1, blast off. Our degree 0 term, which is a constant term. So let's do this. So we have an x to the 5th. Do we have an x to the 4th? We do not. So we're going to need to insert a 0 placeholder. So x to the 5th, 5, 4, 3. Do we have a degree 3 term? Yep. Thank you for letting me know. So minus x cubed. 5, 4, 3, 2, degree 2 term, we do not. So let's go ahead and put another 0 placeholder. Cool, so 5, 4, 3, 2, 1. Do we have a degree 1 term? We sure do. That's our 5x term, so plus 5x. So 5, 4, 3, 2, 1, blast off. Our degree 0 term. Do we have a constant term? We sure do. Fantastic. So again, I said if you can do this problem, you can do this problem. It's just a little bit spicier. But the steps that you do to divide whole numbers are the same steps that you do when you have a polynomial division. The only difference is in the way that we divide. I understand that we are dividing by x squared plus 3, but when it comes to polynomial division, we just focus on the first term. So the question is, how many times does this first term go into this very first term that I see? And I know you can see it, but I don't. So I'm going to bust out a thinking area. So I'm going to speak to myself. So I'm like, okay, how many times does x squared go into x to the 5th? So x squared goes into x to the 5th exactly 3x cubed times. That looks a little weird. Okay. X squared goes into 3x to the 5th exactly 3x cubed times. So let's go ahead and line it up on top of the degree 3 column. Okay, so we have 3x cubed. So we just divided. What do we do after we divide? We multiplied. So let's go ahead and multiply. At this point, nothing gets ignored. We're going to take the 3x cubed and divide it by x squared plus 3. So let's do this. 3x cubed times x squared, I believe that's 3x to the 5th. And I'm supposed to say 3 times x to the 5th, but you understand me. 3x cubed times 3, I believe that gives us 9x cubed. Line it up. Okay, what do we do thereafter? Same thing that you did with this problem right here. You divide, multiply, subtract. So let's go ahead and subtract. Okay, but this is the thing, since we are subtracting more than one term, you have to wrap it up. Okay, so when we subtract 3x to the 5th minus 3x to the 5th gives us 0, or we say it cancels. 0x to the 4th minus nothing else is still 0x to the 4th, and with your permission we're gonna ignore the 0x to the 4th. Why? For the same reason that we didn't put 0x to the 5th. If there's a 0 we ignore, but we don't ignore the zeros over here. Okay, negative x cubed minus 9x cubed, I think it gives us negative 10x cubed, and then I'll tell you why I was stuttering. For me it's very difficult to subtract like this. If we just had whole numbers, where am I? If we just had whole numbers, I was like, okay, let me borrow, do my thing, cool, and get the 8. But when it comes to subtracting polynomials, it's really hard for me to do it like this. So what I like to do is, after we put the minus, then we'll distribute it so we can add the opposite. So I'll be like, opposite of a positive term is a negative term. Opposite of a positive term is a negative term. Now that we distributed the negative, we can safely change it to positive, and then without stuttering, I could handle it with confidence. 3x to the 5th minus 3x to the 5th, 0. 0x to the 4th, nothing else happening, 0. We don't write it for the same reason we didn't put 0 here. With confidence, no more stuttering. Negative x cubed minus 9x cubed equals negative 10x cubed. I understand that before I distributed, the solution looks a lot cleaner, but I feel more confident when I distribute to get the difference. Okay, I think I made a big fuss that needed. Okay, so coming back to the solution, so what do? We divide, multiply, subtract. What do we do thereafter? We bring down the next digit. In this case, we bring down the next term. Do we bring down the 0? Yeah, we don't skip anything. Okay, so we just brought it down. So steps to long division: divide, multiply, subtract. If there's another digit, bring it down. And what happens when you bring something down? You gotta repeat the entire cycle again. Okay, so let's go ahead, divide. Yes, when it comes to division, we do want to know how many times does x squared plus 3 go into this two-term expression. But remember, for the division part only, it works a little bit different for the polynomials. For the division part, it's always how many times does this first term go into this very first term that we see. And you can do it mentally, but it's hard for me to do it mentally. And I love showing my work. Okay, with confidence, x squared goes into negative 10x cubed, exactly negative 10x times. You can cross cancel if you want. Okay, line it up. Alright, so we just divided. Let's go ahead and multiply one more time. Negative 10x times x squared will give us negative 10x cubed. Line it up. Negative 10x times 3 will give us negative 30x. Don't put it right here. Line it up on the column, okay, for the x. So negative 30x. When we bring terms down, we usually bring terms one at a time. But in this case, if we already bumped over to the next column, yeah, you guessed it, we have to bring down the next term as well. I don't want you to memorize like, oh, should I bring one or two? Always bring down one term at a time. And then if after you multiply, you bumped over, then guess what? Bring as many as needed to like be on that same column. Okay, it's too much talking. Okay, so we had just divided, we just finished multiplying, and then we're gonna go ahead subtract. So you subtract using the notation of your choice. So I'm gonna go straight to answer to offer the clean solution, and then I'll do my thing. Okay, when we subtract negative 10x cubed minus negative 10x cubed, I believe gives us 0. So I'll leave it as such. 0x squared minus nothing is still 0x squared, or 0. 5x minus negative 30x, I think gives us 35x. So again, the way I subtracted right now is like the cleanest solution, okay? But it's very hard for me. So let me go ahead, just add the opposite so I can say this with confidence. So when we distribute the negative or add the opposite of a negative term is a positive term. Opposite of a negative term is a positive term. And then we distributed the negative. So let's go ahead, switch it up to plus. And where am I? So with confidence, negative 10x cubed plus 10x cubed, 0. 0x squared plus nothing else, still 0. 5x plus 30x, no more stuttering, 35x. Okay, so we had just subtracted. Let's keep going. So steps to long division: divide, multiply, subtract. If there's another digit, bring it down. Cool. And whenever you bring down, you got to repeat the cycle or spit out the remainder. Okay, so when we divide, so remember, for polynomial division, it's always first term into first term. How many times does the first term go into the first term that we see? So it's hard for me to do it mentally, so let me go ahead and put it in my thinking area. Cool. So I want to know how many times does x squared go into 35x, and in this case it's a lie, because notice how this exponent is bigger than the top exponent. So that's it, we can't continue to divide, so we're gonna stop. Okay, so what is the answer? We are asked to write the answer in the form quotient plus remainder over divisor. So let's do this. So the quotient is the number of times that it goes in cleanly. Okay, the divisor is code for what did you divide by. Okay, you know what the remainder is. Okay, it's your leftover. And although we don't need this for the answer, just for added kicks, I'm going to label the dividend. Dividend is code for what did you divide into. Okay, so let's do this. The quotient is 3x cubed minus 10x. And then we want to add the remainder in fraction form, because we are way too cool to write uppercase R remainder, whatever that is. Okay, so plus the remainder in fraction form. It would be nice if you had the plus sign centered about the fraction bar. The only way that I can do that is if I put the fraction bar first. Okay, the numerator, the remainder is 35x plus 6. And the divisor, where am I, is x squared plus 3. That's our answer. Okay, but for fake extra credit, we're gonna go ahead check our answer. How will we check it? Same way we do with our whole numbers. Quotient times divisor plus remainder should give us the dividend. So let's go ahead and do that. So we're gonna check. We're gonna verify that quotient times divisor plus remainder equals dividend. I write the word dividend because I don't want to put another D. Okay, so the quotient, where am I? Let me zoom out. Okay, so the quotient is 3x cubed minus 10x. We're gonna multiply it by the divisor. Okay, quotient times divisor plus remainder. This is the remainder. Quotient times divisor plus remainder should give us the dividend. Okay, so the quotient is that, the divisor is x squared plus 3, and we're gonna add to it the remainder of 35x plus 6. Okay, 35x plus 6, and by some miracle that should give us the dividend. It has to, because this is our problem. So I'm gonna put a question mark because I'm not quite sure yet. So let's go ahead, FOIL it out. Product of the first terms gives us 3 times x to the 5th. Product of the outer terms will give us 9x cubed. Product of the inner terms, negative 10x cubed. Product of the last terms will give us negative 30x. Cool, let's bring down the rest of the problem. So rest of the terms. Let's combine like terms and verify that we indeed do have the dividend. Okay, we only have 1 degree 5 terms, so let's write it down. For the x cubes, 9x cubed minus 10x cubed, I believe is negative x cubed. For the x's, negative 30x plus 35x will give us 5x. Cool, and then we have one constant term. So moment of truth, did we get back the dividend? So let me go ahead, zoom out. Okay, so it's gonna be a little bit longer to see because it's not in descending order. So we have 3x to the 5th, nailed it. Cool, minus x cubed, fantastic. All right, plus 5x, perfect. And then plus 6, yeah, so we got back the dividend, okay, or original 4-term polynomial. So we totally did it. So I said that we were gonna do a long division and synthetic division, but we're already getting onto the longer side, so we're gonna table the synthetic division for the next video. Thanks, guys.